Okay, hello and welcome back. So writing structs in C++. Let's go over some of the style associated with it. We're using the C++ Google style guide in this course. So, our expectation is that you are following it throughout this course and likely onto the next one, as I do believe 225 uses the style guide too. So this is taken directly from the Google style guide. I'm trying to pull in pieces of information here and there so that it's kind of presented with what we're introducing. However, you will need to open it up and go through it for reference from time to time. So type names, including that of any sort of structs that you're defining, start with a capital letter and have a capital letter for each new word. This is different from variables, which uses underscores to separate out the words. The names of data members are all going to be lowercase and have underscores between the words. We'll see that this varies ever so slightly between the primary two different ways to introduce a user-defined type, struct versus class. But for now, we've only introduced structs, so that's all you have to be concerned with. They look exactly similar to how we've declared or introduced the names of our variables earlier within this course. So we should use a struct only for passing objects that carry data. We'll see here that, so it's going to be aggregates of data. We'll see here that there are better ways to implement types that do more elaborate things, and that's what this line's attempting to communicate. Furthermore, when we're using a struct, the struct must not have invariants that imply relationships between different fields because we're able to access each of those fields directly. So what's meant by an invariant? An invariant is simply something that's always true about something. So if we wanted to put any checks and say, the values within this field of a struct should always be within this range. And even for our contact, maybe a struct necessarily isn't the best approach because phone numbers have a format, and we might have wanted to say that our contacts are always going to have a phone number that is valid. So the right number of digits for the right country, etc. That would be an invariant. So when might a struct be better used? Well, maybe something like a point, whose fields X, Y, and Z could take on all real values, things of this nature. But anything kind of more complicated than that, we'll introduce better ways to go through this later on in the course. So we're also going to want to prefer the use of struct to that of a pair whenever we can, because we can actually provide what it means, what that grouping of information stores, whereas a pair, it's not necessarily very clear. The name of the type is pair, and it has, we're specifying two types. Okay, well, what's actually being held in that? And I think the need for a descriptive variable name would be even more important in scenarios like that. So do you prefer struct to pair? Try not to get lazy and just use pair because it's a quicker option, perhaps. So writing structs in C++, we introduced the basic syntax. We said, okay, you start out with struct. We gave you some naming conventions. We said you essentially can provide the fields within the definition of that struct. And we said, don't forget about that goofy semicolon at the end. These user-defined types are one of the few places where you'll see a curly brace followed by a semicolon, but don't forget it. So we're going to define each struct. So each struct is going to have its own header file. We're going to name the header file the struct name, but in lowercase. And any separation or any kind of word breaks within that name would translate from that uppercase notation into underscores similar to or dashes similar to our variables. So the header file, again, we said these are include guards. We'll get to these soon. Don't worry about them right now, but after we've talked about compilation, you'll see why they're necessary. Here, notice that our definition of struct is using a standard library string. That means in order for the compiler to know what a string is, we better pound include string. And then this is the same definition that we saw before. And the file name for this is just going to be contact.h. Remember, same name as the class, but lowercase. And had it been person contact, it'd be person underscore contact. Again, using the underscore dash to separate out the different words comprising the name. Now, when we'd like to go ahead and use our struct, we just have to remember to pound include the structs definition into the code where we're using it, or into the file where we're using it. So in our main.c, let's say we're interested in using contact. Okay, so I have to bring in its definition by pound including contact.h. And again, that is that file name there. That essentially copy and paste the definition of our struct into this file. At that point, when main is going through the compilation process, the compiler will know what a contact is, as well as what the valid operations can be performed on it and what sort of data it stores. And then we just go ahead using that type as we have before.